All right, welcome back to our Historical Explainer mini-series. Today we're diving into Episode 2, From Physics to Music Publishing, The Origins of HSDB. We're going to unpack a truly wild story today, like how does a background in playing the mandolin and practicing IP law somehow birth a massive computational revolution? Well, buckle up, because we're looking at a completely novel convergence of computation, data, and software rights.
To kick things off, check out this incredible quote from the creator of HSDB himself, Kyle McLean Smith. He literally says that if he hadn't gone to law school, worked in music publishing, and played guitar and mandolin in bands, he, quote, "don't think I would have had the written language skills to think up a database/program hybrid." So his interdisciplinary experience wasn't just helpful, it was absolutely mandatory. He wasn't just sitting in a computer science lab, he was out playing the country music circuit, dealing with the nitty-gritty of legal contracts. That real-world grind gave him the actual vocabulary to conceive a totally new software architecture.
Moving right into Section 1, Nouns, Verbs, and Databases. To really get why Smith's realization is such a game-changer, we first have to look at a fundamental technical divide that's basically plagued computer science for decades.
So historically, we've got two completely distinct kinds of software. On one side, you have your databases, right? These use query languages. Think of these as our nouns. They hold the static data, the objects, the things. Then on the flip side, we have general-purpose software using programming languages. These are our verbs, the instructions, the logic, the actions. And for years, these two have lived in entirely separate worlds. They've required these incredibly complex, friction-filled translation layers just to get the verbs to talk to the nouns. It's kind of like having a massive puzzle where the pieces don't naturally fit together.
But here is the solution: the Hierarchical Script-Database, or HSDB. What this does is unify execution and persistence inside a single JavaScript kernel. By using the exact same language for data retrieval and scripting instructions, it completely merges the application layer and the database layer into one self-evolving runtime kernel. Seriously, think about that. Instead of having a giant pile of nouns over here and a pile of verbs way over there, someone finally put them together so you can write dynamic, living sentences and paragraphs. It's absolutely brilliant.
All right, Section 2, Law and Music Publishing. So you might be wondering, how do you actually go from spotting that technical problem to building this architectural solution? Well, it circles right back to those music and law roots we were talking about earlier. Smith's unique career trajectory literally provided the blueprint for this architecture. Look at this path. He goes from competing in Belmont's Country Music Showcase to working in music publishing right on Nashville's Music Row, and then eventually practicing intellectual property law on Toronto's Bay Street. During those years, Smith was observing how insanely complex music rights, royalties, and licenses were managed. It was this deep dive into tracking infinite chains of musical derivatives that sparked a totally new way to think about software logic and information theory.
Which brings us to Section 3, Wolfram, Physics, and Rights. This is really the theoretical core of HSDB. And to fully grasp what Smith achieved here, we need to contrast his applied work with the highly abstract theories of the famous physicist Stephen Wolfram.
Okay, so both of these thinkers look at computation through the lens of exploring all possible paths, but they apply it to radically different universes. Wolfram, as you probably know, uses this concept to decode theoretical physics, genetics, and basically simulate the natural universe. Smith, on the other hand, takes that exact same mathematical rigor and applies it to something surprisingly complex, the music industry. He uses all possible paths computation to manage infinite branching music licenses, track risk, and handle massive royalty collections. He's treating code not just as functional instructions, but as a dynamic, infinitely branchable creative asset.
Now, to successfully process all these infinite licensing paths, Smith had to seriously innovate on the math front. He entirely bypassed the standard cyclic torus loops you'd normally find in database architecture. Instead, he used something called a Pythagorean metal point-at-infinity looparound. I know, that's a mouthful, but basically, this mechanism pairs a finite modulo sequence, which represents iteration, with positive and negative infinite number line sequences, representing fractal and recursive structures.
And the mathematical engine driving this infinite stack of unique input-output data is governed by this specific formula right here, the scale symmetry-base exponent. This formula generates scale-symmetric geometric patterns that actually serve as the mathematical coordinates for the data structures inside the database. Smith tied these structures to Fibonacci sequence approximations and the golden ratio. This creates non-halting, self-reproducing coordinates that let the database infinitely expand without ever breaking. Pretty wild, right?
If that all sounds a little abstract, just think of it like this visual of the famous Mandelbrot set. Just as this classic fractal branches out infinitely while always maintaining a strictly self-similar core structure, HSDB maps the infinitely branching derivatives of music rights through self-similar tree coordinates. It is literally a database structure built on the geometry of nature, allowing this intricate, never-ending web of contracts, songs, and transactions to be tracked flawlessly. Let's move on to Section 4. Patenting open source software, because this is where we see how this beautiful mathematical architecture transitions into a groundbreaking business strategy and IP framework.
So, to protect this methodology, Smith filed a non-provisional patent, U.S. Patent 12.664.142 via Klarquist-Sparkman. But look closely at the structure of the patent itself. It explicitly outlines a tree database structure designed to mathematically enforce structured attribution. You've got a root node overarching the whole database, which branches down into text documents for licensing contracts, then branches further into song metadata, and finally into multi-level transaction logs for performance royalties. The legal framework is literally built right into the architecture of the database.
And honestly, this is where his Music Row background truly shines. Smith didn't file this patent just to lock his software inside some proprietary vault. No. He used it to establish a framework entirely parallel to the music industry. Think about it. In music publishing, a songwriter retains ownership of their hit song while licensing it out for massive distribution. In that exact same way, Smith designed the HSDB patent to act as a good shepherd for open-source distribution. It's a built-in legal mechanism to enforce structured attribution and royalties for developers, transitioning code into an open-source model safely.
Which leaves us with a profound, completely paradigm-shifting question to wrap up our explainer today. By unifying the application and the database, and wrapping it all in a legal framework inspired by music publishing, HSDB challenges everything we know about software intellectual property. Just imagine an open-source ecosystem where developers are finally paid and protected exactly like rock stars. It's a fascinating vision of the future driven entirely by the mathematics of infinite possibilities. Thank you so much for joining us for this explainer, and as always, keep your curiosity hungry.